Thank you everyone for your patience. 2:03, let's begin. So thank you everyone for joining us today, spending part of your time. We're going to be talking today about NYCHA PACT heating. We have a phenomenal panel to discuss energy efficiency projects at NYCHA buildings. For anyone that is curious, this will be recorded, and a copy of the slide deck and the presentation will be available. We'll be sending it out shortly after the meeting. For the agenda, we're going to do some brief introductions, and we'll get straight into NYCHA PACT heating. We'll have a review on Local Law 97 and talk about steam system balancing. We'll have a couple of case studies, and we'll open it up for a Q&A session at the end. So first, briefly about us, Building Efficiency Services. We are a contractor that helps buildings with their steam distribution systems, as well as hydronic and electric heating systems. We also help buildings comply with Local Law 97 and file and capture any incentives. My name is Ari. I'm a VP at Building Efficiency Services. We have Eli on the call from our team as well, who will be helping us moderate the Q&A. With us today is Tunstall, Woody Tunstall and Scott Mallow from Tunstall. We've done a lot of projects with Tunstall over the years, a couple of NYCHA PACTs as well. These are some of the best guys in the business, white glove service. They come down to the project and really make sure that everything is run smoothly. Really phenomenal people. We have also with us Marissa Morris from New York City Accelerator. New York City Accelerator is a task force, of course, from the mayor's office that can help you navigate Local Law 97. Marissa is an account manager and an excellent resource. We've done a lot of work with her, and we'll have contact information for everyone at the end. So let's move forward and get into NYCHA PACT heating. I'll call on Woody and Scott to please go from here.
Hey, Ari, how are you?
Hey.
I just, before we get started, I actually prepared a written opening for us. I kind of liken this to my Academy Awards speech, where I come up to the podium and I forget to thank people. So if it appears that I'm reading something, it's because I am. So I just want to say good afternoon to everyone. Thanks for joining us. As Ari mentioned, I'm Scott Mallow. I am the Director of Energy Solutions for Tunstall Corporation, and we are delighted to have this opportunity to help discuss our role in the New York City Housing Authority RAD program. We want to thank BES for organizing this presentation, along with Marissa and everybody at the New York City Accelerator as they continue to do their amazing work. At Tunstall, we understand that RAD is not just a renovation initiative, it's a transformative approach to preserving and enhancing affordable housing in New York City, improving quality of life, sustainability, and longevity for thousands of residents. Tunstall's thrilled to be one small piece of this very large puzzle. As experts in these kinds of systems, we are committed to delivering solutions that align with NYCHA's goals for energy efficiency, resident comfort, and cost-effective sustainable upgrades. Today, we'll cover how our solutions support the program's needs, focusing on creating a more energy-efficient environment across NYCHA properties. Thanks for having us here today, and we're excited to share our insights and capabilities with you. So as we hear on the first slide, there are a number of different ways that these NYCHA properties can upgrade their existing systems, as they embark on a RAD PACT project. And the three that we're going to talk about today for the different ones that we've been involved in are very simple. It's hydronic optimization, steam optimization, and the straight electrification or a hybrid electrification in some cases. So next slide. We actually were very involved in the NYCHA RAD PACT very early on. We're involved actually in the very first one, which was the Ocean Bay Bayside program. Basically, these were MDG was the building and design. The installing contractor was Platinum Energy Group, and the heating scope from our perspective was a steam to hydronic conversion. I'm actually going to have Woody jump in here too, because he also has a great knowledge of these buildings and what some of these systems were, prior to us getting involved.
Yeah, hey, thanks, Scott, and thanks, everybody. Appreciate your time today. So in this particular project, there was existing infrastructure that was at this complex. This NYCHA complex was a boiler plant where they were producing low pressure steam and providing through underground piping to each individual building. At each individual building, there was a main valve which controlled. It was a two pipe steam system with a vacuum return. So there was a vacuum pump, and essentially what they were trying to do was, or what they were doing was providing two pipe steam to the radiators. It was a 24 building complex, I believe, and there were 4 or 8 story buildings. The developer wanted to apparently the life the boiler was had used its useful life, and the underground piping was in disarray. So they decided to convert the complex over to two pipe hydronic with hot water. So our participation in this specific project, along with Williamsburg Houses, which is one of the PAC bundles that was in Brooklyn with the same developer and same installing contractor, was to install a European style large thermal mass radiator. What they did was they put boilers, smaller condensing boilers in each individual building. They were able to use the existing core drillings of the steam piping and run new risers, both vertical risers and horizontal piping, over to the individual panel radiators themselves. And the panel radiators are provided with an integral shutoff valves and thermostatic radiator valve. So it allowed the tenants to kind of have control over the amount of heat in their apartment for the first time ever. Previously with the steam, there was just an on-off valve, which basically the tenant either had it on or they had it on off. No real thermostatic control. So once again, they were able to decentralize the steam, provide individual boilers for the buildings themselves, and provide a level of comfort that the tenant hadn't seen before. We provided probably close to 12,000 to 20,000 individual panel radiators on this with thermostatic radiator valves, and then some pipe cover on the horizontal section, which connect basically the riser in the corner of the room over to the panel radiator, and the panel radiators were centered underneath the windows. You can go to the next slide. What we're trying to do, I think, is just give you 2 examples of kind of a hydronic optimization. This project is actually ongoing. It's called Park Rock and Reed Apartments. It's a bundle that's also in Brooklyn. This is a hydronic optimization as well. So this is a little bit more challenging as these are scattered sites. I think there's a total of 1,700 apartments under this bundle, and the buildings are located, miles apart. Pretty much all 3, 4, 5-story kind of walk-ups with a couple of larger buildings scattered in here and there. This was interesting because the scope of work here was, because of some of the weatherization that they did in the apartments with the casing of the building, insulation of the building, and the new window replacements, they were actually able to the existing system was hydronic. They were actually able to lower the temperatures out of the boiler systems and still meet or exceed the output of what the existing radiator element had. So that being said, with the total scope of work inside the apartments, including, complete new bathrooms and kitchens and flooring and windows, they had kind of this older residential style fin tube baseboard, which basically was around the perimeter of the buildings. So our team here, and we're a metal fabricator, was able to design a slip-in enclosure. That's kind of the right picture there, which helped, make the appearance of the existing much more attractive to the tenants. Let's trying to think anything else about this project. Yeah, what happens in a situation like this is the alternative, some of the largest parts of these projects is really the labor to install or change out. They're all PLA agreements with prevailing rate, and this type of system slipped over the existing, which helped allow kind of reduce the cost on the overall installation of the scope of work. We're currently working on some other some hydronic optimization projects right now. One of them called Frederick Samuel Apartments in Harlem. And we just finished up a project in the Bronx called Union Ave Consolidated. Next slide. We're going to kind of slide in here after this slide here. We'll kind of talk into some of the steam optimization. So this particular Rad Pack bundle is called Linden Houses. It was located in the Bronx. I believe it was a total of, I think it was 18 buildings. The developer was L&M Builders. The installing contractor was your very own Building Efficiency Services. The heating scope here was to optimize the existing steam system. So I believe in this particular project, along with the next one we're going to mention, the boilers were fairly new. This once again, these are central steam campus where the low pressure steam is created at the boiler plant and goes into each individual building to provide the domestic hot water as well as the heating for the building. So in this instance, what we did here was we work with Building Efficiency Services very closely, and we provided a new decorative enclosure which encapsulated the existing element and gave the appearance of a new radiator inside each individual room, along with thermostatic radiator valves, steam trap upgrades, orifice plates, and I think that, and also Building Efficiency Services did a lot of insulation on this project as well, both the risers, the vertical risers, and some of the horizontal runs to the individual radiators themselves. So this picture on the left is kind of what was existing. The picture on the right is kind of a finished product. Obviously, windows were replaced. A lot of weatherization was done as well. So once again, the tenants, now had individual control over their radiators, providing however much heat that they desired. Next slide, Ari, please. Very similar to the Linden House projects. This is a project which is also ongoing called Edenwald Houses. This one's located in the Bronx. It's a 40 building complex. Same developer, L&M Builders, same installing contractor, Building Efficiency Services, and kind of the same scope. The only difference here that I'd like to point out is that the existing radiators, which were in the individual apartments themselves, were freestanding cast iron. And the developer contacted Building Efficiency Services along with ourselves and asked us if we could make a decorative enclosure which encased the existing and kind of encased the existing and also allowed not kind of having to repipe it. So in these buildings here, they have vertical risers in the corner of the rooms, and they have horizontal going to the radiators themselves. So we were able to design a little nifty kind of piece which allowed for some cutouts on the radiators to allow the horizontal piping to still continue to connect to the radiators themselves. Once again, Building Efficiency Services installed the radiator covers, the thermostatic radiator valves, the steam traps, orifice plates as well. So there's some other projects going on right now with this type of unit as well. And just so you know, like I said, we're a complete manufacturer of metal products, so we can design any type of enclosure that's desired for the buildings that you guys may have. Next slide. Talking a little bit about the first two that we talked about were the hydronic optimization, or when the source is still hydronic. The last two, obviously, we're talking about a little bit of steam, and now we're going to kind of get into some of the electrification projects that we've participated in. The first project was called Whitney Manor. It's actually in Yonkers, but it's also tied to a project part of the Rad Pack bundle of the Union Ave Consolidated called 1325 Franklin. And in these two particular buildings, they went 100% electrification for the properties. They ran, the installing contractor was Renewal Construction, and basically what they did here was the existing infrastructure was either a hydronic infrastructure at 1325 Franklin, or it was a baseboard electric resistance kind of heaters in Whitney Manor. And what they did was they used a air to water heat pump, which was located, they installed them on the roofs of the buildings. And with the air to water heat pump, they were able to tie that into a hydronic loop, and our participation was the fan coil units, which were installed in the individual apartments themselves. So they soft ducted the fan coils. Basically, what they did was they installed them below the entryway of the apartment, and what we did was we soft ducted them into each room of the apartment. So the living space, the bedroom spaces. And the water temperatures here, and I can have Rocco kind of touch on this real quick, but I believe, Rocco, the max water temperature we're running out of these fan coils is somewhere around 100 degrees, maybe 95 degrees. Does that make sense?
I think this project is 120 degrees.
Oh, 120 degrees. Okay. But 1325 Franklin may be a little bit less, I believe.
Yeah, I think that one was 110.
So they was a 2-pipe fan coil, and they have, hot water in the colder months and cooling in chilled water in the warmer months. So this is a complete heating and cooling system. Once again, each tenant has individual control over their heat now, as opposed to where it was in the past. Next slide, Ari. This is part of the Union Ave Consolidated project as well. Developers, the Archer companies, the installing contractors, Renewal Construction. This is a project called 905 Eagle. It's located in the Bronx. And here we are installing our double ducted heat pump units standalone. So these can come at 100, I'm going to let Rocco talk a little bit here, but 115 volt standard kind of plug-in type unit. We'll show you a picture of what one looks like after this. This was kind of an easy one, because what the building had, what the infrastructure had here, was they had existing AC sleeves, which were installed underneath the windows. So with these double duct heat pumps, whether it's ours or somebody else, you have to move air from in and out of the building. And we designed and installed a custom AC sleeve, which fit inside the existing hole of the building, and allowed these to mate up next to it and to install it underneath the windows. This particular project, they electrified the entire building. I believe they used induction stoves for the heating, for heating, cooking heating, and they rewired the building to 208 volts. Does that sound correct, Rocco?
Yes.
Okay. The next slide kind of shows a little bit of what these double duct heat pumps look like. Here with some of the outputs, and if anybody wants any cut sheets on these, we're happy to reach out. We can provide these with you, but this kind of gives you the output at specific temperatures for both the heating and the cooling capacities. The top right portion of this picture here is what that AC sleeve looked like, with the two round holes for the ducting of the air of the unit, and the bottom left kind of picture shows what's called a window adapter, right? So the biggest challenge with these particular units is the ability or the need to potentially have to core drill through the building to get the air in and out of the unit. And what we've done is we've kind of designed some of these window adapters, once again, the bottom left picture here, where you can install this adapter and mate up our heat pump to it, and you don't need to drill any holes in the side of the building. Basically, we're able to move the air through the existing window that's there. Now, once again, not every building would qualify for this type of adapter. Very wide windows are much easier for us than narrow windows. So we have to be able to get the CFM through that adapter in order for the heat pump to work 100% efficiently. Next slide, Ari. So, which one do you go with, right? And, why does one choose one over the other? Well, it kind of depends on what the budget constraints are, what the existing infrastructure is, and what are some of the structural requirements. So I'll tell you a quick little story, but there's a project going on right now called Eastchester Gardens. And originally, when this thing was designed, it was designed around the potential use of using geothermal and using some type of emitter with a fan in the apartments themselves. Well, the budget constraints didn't allow for that to kind of go through. So they then designed it around a double duct heat pump. And they realized that it was really challenging to get the outputs in the larger rooms in these apartments there. So, and the existing infrastructure didn't allow, because I believe it was a preservation building, didn't allow for them to actually core drill through the building. So then what they did was they said, okay, let's put individual condensing boilers in the units in the individual buildings themselves and run a hydronic loop. Well, NYCHA came back to him and said, guys, I don't think we can do this. And the reason being is that in 2017 and 18, we spent $30 million on a new boiler plant, right? So we'd like to see the existing boiler plant stay there. However, what they didn't do, and they didn't have the funding to do at the time, was to dig up and replace all of the direct burial piping. So the direct burial piping was out of its extended life. So ultimately, it kind of came back to what they're going to do in this instance, in this Eastchester Gardens one, is they're going to leave the existing boiler plant. They're going to run new direct burial piping into the buildings. They're going to provide new steam to water heat exchangers, and they're going to pipe in new risers and a new loop and provide the panel radiators like the first two buildings with that. So this will be a steam to hydronic kind of conversion. Yeah, that's kind of what we got. Kind of touched a little bit on the three different avenues and why we do it. And if anybody has any questions after, let us know. We're happy to work with you. Or if you guys have any projects, happy to give you some suggestions as well. So I want to thank everybody for the time.
Thank you very much, Woody, Scott. You can screen capture now the contact information. We'll have it at the end as well. And we're going to move on to local law 97. We'll call on Marissa from New York City Accelerator. Please take it away, Marissa.
Yeah, thanks, Ari. Hi, everyone. Good afternoon. Thanks so much for joining us this afternoon and spending a little time learning everything. My name is Marissa Morris. I'm an account manager with the New York City Accelerator program. We are a totally free advisory service, and we work with thousands of buildings across the city to lower emissions and, of course, help with local law compliance. Who's eligible? It's any privately owned New York City building that's over 5,000 square feet, and anyone smaller than that, we can refer to some partner organizations. How does it all work? You reach out to us and you get connected with a dedicated account manager, and then you receive objective advice customized to your needs. And then how much does it cost or what's the catch? It's absolutely no cost or catch. We are as I mentioned, a free advisory service through the Mayor's Office of Climate and Environmental Justice. So we're here to help as much as you would need. But with that being said, next slide, please. I'm going to talk a little bit about Local Law 97, why it's important and why it's relevant to this conversation. Local Law 97 was passed in 2019 as part of the Climate Mobilization Act, and it aims to reduce emissions in all buildings in New York City, or at least most buildings in New York City that are over 25,000 square feet. And the emission limits begin this year. It's super important. If you heard about it in 2019 or, you've heard about it more recently, there have been multiple updates to this local law. There was a first rule package that came out in 2022 that provided some more clarity, and a second package of rules that came out in 2023 last year that clarified more requirements for Article 321, which is what NYCHA PACT buildings would fall under. So if you have heard of it, but you're not sure of your requirements or you're not sure what those updates are, that's what we're here for, is to make sure you have all that information so you know what your plan is to comply moving forward. So I won't dive deep into each of the pathways since we're talking specifically about NYCHA PACT buildings, but I want to note that those buildings fall under what they consider affordable housing for Local Law 97. So these are buildings that have at least 35% rent regulated units, or HDFC co-ops, or buildings with one or more units with federal project-based funding, and NYCHA PACT RAD buildings. So we're going to focus mostly on Article 321. However, I will point out that other affordable housing, so if you have under that 35% rent regulating units, you'd be subject to delayed compliance and wouldn't have to start doing and meeting those emission limits until 2026. And then if you happen to also work with a Mitchell Llama rental that doesn't have that federal project-based funding, or if you have a building with no rent regulated units, but at least one or more that are income restricted, they will fall under 2035 pathway, which they also have delayed compliance till 2035. So just pointing those out, but we're going to focus on Article 321. So I already mentioned what housing types fall under Article 321. The compliance requirement for these buildings is very different than other buildings under Local Law 97. The compliance requirement here is that you'd have to do one of two things. You either would need to comply with your 2030 emissions limits by the end of this year, so by the end of 2024, or implement the applicable prescriptive measures by the end of 2024. For reporting, there's only one report due next year, by May 1st of 2025. And this is different from Article 320 and the rest of Local Law 97 because they have to do annual reports. And there are penalties associated with this. There's a penalty of $10,000 for failure to report and a failure of to comply penalty of $10,000. So super important to make sure that you have meet the requirements of either of those compliance pathways so you do not get those penalties. And there are some penalty mitigation opportunities, and I'll talk about that in a little bit. So you may, if you need some extra time to comply, there is some extra time out there. So looking at the compliance timeline in detail at a glance, emission limits begin this year. They've already begun, and the compliance deadline for Article 321 is the end of this year. The first compliance reports, and specifically the compliance report for Article 321, is due next year, May 1st of 2025. And then I mentioned those two buildings of those two types of buildings that could fall under the 2026 pathway or fall under the under the 2035 pathway, excuse me. So if you have any buildings that you work with that might have delayed compliance, of course, reach out to us and we can let you know what that looks like, when you would need to start reporting, and develop a plan with you to be able to meet those reporting and compliance deadlines. Next slide, please. So talking a little bit more about Article 321 and those two different pathways that I mentioned. The first one is demonstrating that for 2024, your building is below the set 2030 emission limits. So you use your local law 84 benchmarking data to determine if you meet those emission limits. And then by May of 2025, submit a report to DOB certified by a registered design professional that your building is under that 2030 set emission limits. Or you would implement all the applicable prescriptive energy conservation measures, or PECMs. And I'll show you what all of those are on the next slide. And then by May 2025, a report needs to be submitted to DOB by a retro commissioning agent. These are the different 13 prescriptive measures that affordable housing under Article 321 would need to complete by the end of this year. Super important that we're talking about the heating systems of your properties because a lot of them has to deal with the heating system and making sure that it is maintained and working optimally. I won't read through every single one of them. Just know that the ones on the left are some general measures that apply to most buildings. The ones in the middle are specific to steam systems. So if you have a one pipe or a two pipe steam system, you'll have to look at those three in particular as they may apply to your building. You need to complete them, and some other maintenance measures. So those are ones that are just working towards like the general maintenance of your building, making sure that like temperatures are set to specific points, there's no leaks, et cetera, et cetera. If you can go back to that slide really quick, Ari, if you don't mind. Thank you so much. The one thing I will mention here is that there is help to finance and pay for these different prescriptive measures if you're getting this work done. So if you are speaking to contractors, you're getting that proposal back, there are rebates out there and different things, specifically the ones that have the blue check mark next to them, can be incentivized through the AMEET program. That is a program that is for affordable housing, in particular through your utility providers. So if you are interested in those incentives and you want to figure out navigating that landscape, that's what our program is here for. Super quickly, if you're working with any of the buildings that fall under those other two pathways, or if you're working with a building that it may make more sense to meet that 2030 emission limits than it does to do the prescriptive measures, you might want to follow, that 2030 pathway. So this could be good for affordable housing that is performing close to the emission limits, or they're planning deep retrofits. If they're doing an oil to gas conversion, if they're doing electrification, it might make more sense to look towards the 2030 pathway. So your plan of action here is determining your building's performance in relation to the emission limits, creating a building energy efficiency plan, and then choosing projects to reduce your greenhouse gas emissions to meet those limits. So I mentioned I'm going to talk a little bit about the penalty mitigation opportunities. So let's go ahead and move into that. So as I mentioned, by the end of this year, you need to be in compliance with Article 321, or you could face two different penalties, a lateness penalty and a non-compliance penalty. But there are penalty mitigation opportunities for buildings that are making those efforts to comply with Local Law 97. So those three things are unexpected or unforeseeable events. So this is if your building is damaged as a result of a disaster, including but not limited to hurricane, severe flooding, or fire, or if you're doing an eligible energy conservation project. So if you've received funding from a housing agency as of November 15th of 2019, demonstrating that what's being implemented will bring you under your emission limits or meet the requirements for Article 321, you'd be able to have a little bit more time to complete that project. And there's also mediated resolution. This will give you some extra time to comply if you're working towards Local 97 under one of the two pathways. And we can move to the next slide because I have some more details on that one. So under mediated resolution, you would be able to apply for this and either meet your 2030 limits prior, as long as you're meeting your 2030 limits prior to 2030, or planning on implementing your prescriptive measures by the end of next year. So what you would do is make sure that you have your compliance plan ready. So how are you planning on meeting either of those two pathways? Your local law 84 data ready to go, and your benchmarking report ready to go, and your attestation of how you're out of compliance. So your list of measures of, okay, we need to complete these three, and here's how we're going to do it, or your 2030 plan of we're over the 2030 limit, but we're planning on being under it, and here's how we're going to do it. You would submit all of this as your report that you need to submit May 1st of next year. And once that is submitted, DOB would grant the extra time to be able to comply with Local 97. So in order to pursue mediated resolution and be able to have this extra time, you have to figure out and plan how you're going to comply as of now, because you'll need to have contractors on board. You'll need all of that information to be able to submit your compliance plan. So make sure that you're working towards it and you have that time to be able to speak to contractors and get your compliance plan ready to submit next year. I'll highlight one really good opportunity. There is the Con Edison Local 97 limited offering for affordable housing. This is a joint effort between the New York City Accelerator Program and Con Edison specifically for buildings that are looking to implement those prescriptive measures. So if you're looking to do that, there is incentives out there, as I mentioned, for those prescriptive measures. So if you're looking to do any of this work, it is based by dwelling unit. And there are specific eligibility requirements for this program, but reach out to me directly. I'm happy to talk more about this program and be able to see what incentives you could apply for. And this is just, some free money out there to be able to complete it. So before you get any work done, make sure that you are looking into incentives. If you need financing help, that's what our program's here for as well. We can connect you with our financing team. So just, let us know what you need. And how do we specifically help a building with Local 97? First, what we do is help clarify those requirements, figure out what pathway do you fall under, and identify the greenhouse gas emissions and compare them to the limits. Does it make sense to do the 2030 pathway, or does it make sense to implement the prescriptive measures? Once we do that, we will help identify any applicable financing or incentive programs that your building would qualify for, and then assemble a team of service providers like the contractors that are on this call today to be able to help complete that work at your property. And then we'll help provide project management and support through project completion. If you have any questions, you need, a retro commissioning agent or a retro design professional to complete that report next year. That's what we're here to connect you with. So if you are at any stage of Local 97 compliance and you just need some extra support, that's what our program's for. So feel free to reach out to me directly or take a look at our website for some more information and connect with an account manager. But with that, I'm all done.
Thank you very much, Marissa. And we're going to now talk a bit about steam system balancing. So a couple of years ago, there was a report by Urban Green Council, and it talks specifically about the potential savings for steam system buildings. And because, to do a lot of times a conversion is a very, a very expensive project. Sometimes using your existing infrastructure can really reduce your carbon emissions and expenses by up to 20%. So common problems that we encounter with buildings that are not properly balanced, you have, varying hot and cold apartments. Tenants are opening their windows and literally the energy is just going out the window, clanging and hissing pipes, leaky radiators. And, some of the solutions to fix these issues are actually on the 13 measure list, the 13 PCMs that Marissa spoke about. And we work together with Tunstall on a couple of NYCHA packs to implement things like TRVs, orifice plates, steam traps repair. And success is really only assured with, a complete comprehensive look at your steam. A lot of times buildings over the years, a number of management companies or crews will fix the building here and there, and over the years there's a lot of patchwork of fixes that were made, but by taking a real comprehensive approach to the heating system, you really get the best balancing and energy efficiency. So some common area and in-unit solutions. We have steam trap repair, which you'll find both in the common areas and in two-pipe steam system. You'll have them on individual radiators. TRVs are the individual radiator controls. And for the 13 PCMs, it's really required for two-pipe steam system. For one pipe, it's only if you're getting heating complaints. Pipe insulation and orifice plates. Orifice is a big one. Woody touched on that earlier. It's something that we did together at the Linden houses. Orifice plates are really phenomenal tool to reduce ongoing maintenance expenses. Steam traps will fail, of course, every about 3 to 5 years, and that requires not only the expense of the steam traps and having the crews get access to all the tenant units to make sure that the entire building is then balanced. Orifice plates, by regulating the amount of steam that's entering into the radiator, you reduce the wear and tear on the steam traps, or eliminate it actually, and therefore eliminate the steam trap maintenance. And master venting, of course, will allow steam to pass through easily through the system, reaching every unit and riser in the building. BES offers a Article 321 turnkey solution for Local Law 97. So that goes from the initial site survey. We'll have a crew go down there and provide a comprehensive report on the 13 measures, where you're in compliance, where you might need to do some work, and we'll provide that report and a proposal to do any work that is currently not in compliance. We'll help you apply and capture any incentives, of course, through the full installation, and then help you do the regulatory filing, whether that's now in May of 2025, it's coming up in about 6 months, or if help you get the extension to allow a little bit more time to be able to do the work. We handle pre and post inspections as well, and solutions for Local Law 97, Local Law 88, 84, and 87. We our crews in the field working in the buildings are completely paperless. We are using technology to track and all the work that's being performed and provide real-time reporting to management. This is actually a screen capture of what we call a scorecard. This is actually from the Linden houses. And you can see by the green that we have a very good track record of working with management and the tenants to get access to all the units to be able to perform the in-unit work. A couple of questions that we have asked to the DOB. These were emails that we had sent directly to the DOB looking for some guidance. There was some confusion about radiant barriers and whether or not they're needed for one pipe steam system radiators. And basically, it was explained to us that it's really a tandem with the TRVs. So in those cases, which would primarily be two-pipe steam system, you're going into the radiators to do the TRVs, then radiant barriers are required. It's one of the 13 measures. For one-pipe steam system where you're not going in, it's not strictly required. Another question that we had a lot from our clients and questions on webinars in the past is, well, what about this $10,000 and $10,000 fine that Marissa mentioned earlier? Is that a one-time fee fine, or can that be repeated? And the DOB wrote back to us that they reserve the discretion to issue recurring penalties. Certainly, we want to avoid that. You can avoid that by at least filing $10,000, and then the compliance part as well. We can, of course, BES help you with the compliance and not have to be faced with, possibly recurring penalties. I want to take a look briefly at a couple of case studies before we go on to the Q&A session. So first we have an oil fuel building in Queens, pre-war building. Now, the thing about oil buildings, because they are not getting gas from the local utility companies, a lot of the incentive programs are through them, so there are less available incentives for oil fuel buildings. There could be some for electricity if let's say your lighting, but if reach out to us with any questions about that. But in this particular case, we were able to have saved the building a 15% energy reduction and over 3,000 gallons of oil fuel a year. And then, of course, NYCHA PACT Linden, that's the one Woody was, gave a pretty in-depth case study on. What would be interesting maybe to note on this is that we used a program called the AMEP Comprehensive Program, and that works with a number of points. If you're doing a required number of measures, a really phenomenal program for affordable housing. And the project overall experienced an 18% energy reduction after working with Tunstall and implementing, all the measures. So I'd like to now open it up for some Q&A. We have Eli with us, our senior project manager, and Eli, if you can take a look at the Q&A section and see if we have any questions in the audience. I'm going to, in the meantime, post the contact information for the presenters today. And again, this is recorded. We will send out a recording and a copy of the deck shortly after the webinar. Eli?
Yes, first off, I want to thank everyone for participating. Thank you, Ari, for wonderful presentation. Woody, Scott, and Marissa, of course, always a useful resource. Let me just say we have a couple of questions. If anyone has any additional questions, please don't hesitate to type them out in the Q&A tab. So a couple of questions we have right now is for steam systems. How effective is this strategy in comparison to Kelvin Cozy Smart thermostatic radiator enclosures?
So this is Woody, and I'll say there's applications for our product, and there's applications for the Kelvin Cozy Smart Radiator product as well. Ours is a thermostatic radiator valve with a steam trap and/or orifice plate and a decorative enclosure. Theirs is a little bit more sophisticated. I think that you'd want to take a look at the return on investment. You'd want to take a look at what potentially can break and what the replacement costs are. So if you're talking about a computer with a fan compared to a non-electric thermostat, there's going to be a difference there. But ultimately, I can tell you this much. We actually know the Cozy guys very well. They're a good bunch of people, and they have a great product. And I feel we do as well. So,
thank you, Woody. And secondly, we have did you increase the surface area of the fin tubes or increase the fin tube elements to handle low supply water temperatures in case facility would like to electrify using AWHP in future?
Yeah, that's a great question. This is a great question. So, the answer is in these particular case studies that we mentioned, we did not. However, we're working very closely with the Association of Energy Affordability located in the Bronx right now, and I can see that the gentleman listening here, Asit Patel, is listening, where we're going to start doing some partial electrification buildings. And what I mean by that is they have some existing gas-fired boilers, hydronic loop buildings, smaller buildings, some HUD buildings, and some CPC buildings where maybe there's a total of 15 to 50 apartments in those buildings. And what we're doing is we are going to replace the hydronic fin tube with that panel style radiator. And we're going to size the panel style radiator for what the output would be if they were in the future to electrify to an air to water heat pump, like what the gentleman's asking. So with the ability to have the thermostatic radiator valve, the way that the thermostatic radiator valve works is that when the room is satisfied, it shuts off the flow to the radiator. So, let's say, for instance, the the thermostat is set to 72 degrees and a room temperature drops below to 71 degrees. Well, what the thermostatic radiator valve does is it only allows enough water and or steam into that piece of equipment, that radiator, to then heat that room back up to 72 degrees and it shuts off. So that being said, even though we're going to oversize the radiators for the current application, where what they're doing is, as opposed to running 109-degree water temperature out of the existing boiler, they're actually going to put a three-way mixing valve in, reduce that temperature to 140. We're going to provide the radiators at an output of 120 degrees, knowing that we have the fail-safe of the thermostatic radiator valve not overheating and with the ability to electrify in the future. So it's a great question. And I think that looking at all these different types of projects, if you are going to electrify, particularly using hot water, so hydronic, is to make sure that if you do lower the temperatures in the future, that emitter would still be sufficient at those lower water temperatures. So yes, this is definitely something that we have the ability and we've done in previous projects.
Amazing. Wow. Thank you very much, Woody, for the in-depth response. That is all the questions that we have currently. I'll send it back to Ari.
Okay, if there are no other questions right now for the panel, then we will begin to wrap it up. So shortly after the presentation, we will send out a copy of the slide deck and a link to view the presentation in case you missed something or want to review something. Please capture also the contact information up on your screen. We've done a lot of work together with Woody, Scott, Marissa as well. Really phenomenal people. These are the good guys in the business and really, really helpful. And if you have any other questions, please reach out, and want to thank everyone for taking time out of your day today and looking forward to seeing you again soon. Thank you, everyone.
Thank you.